Alright, so I want to go over this question we have in front of us. I push downward with a force of 100 newtons and to the right with a force of 50 newtons. You can have more than one applied force. You can have as many applied forces as possible. In this case, we want to label these both as force applied in our free body diagrams. The first sentence says I push downward, keyword downward, so we have a downward force of 100 newtons, and to the right with a force of 50 newtons on a 1 kg, 1 kilogram book. Alright, so we just read that, 1 kilogram, we know that kilogram is the unit for mass, M stands for mass. At rest on a table, at rest on a table, that means it's not moving up or accelerating downward. The book also moves at a constant speed. Both of these hints tell us that our forces will be balanced. Find the coefficient of friction between the book and the table. Use G is equal to 10 meters per second squared. So we're looking for the coefficient of friction, that is mu. We are given that the acceleration due to Earth's gravity is 10 meters per second squared. This is rounded from 9.81. Alright, let's go back to our free body diagram. In our free body diagram, we know that this book is on a table. That means there is a force of gravity. And this force of gravity is equal to mass times acceleration. Due to gravity, Fg equals to mg. That gives us 1 kilogram times 10 meters per second squared, which gives us an Fg of 10 newtons. Fg equals 10 newtons. Alright, it is once again at rest on the table. If it's at rest on the table, we'll have a supporting normal force that is equal to both of these forces. If the normal force were not equal, then the object would be accelerating either up or down. Fn is equal to 10 plus 100 is equal to 110 newtons. We also know that the book is moving at constant speed. Well, constant speed means that all of the forces are balanced in the direction that the book is moving. So left and right are equal. F applied is equal to 50 newtons. That means our opposing force of friction is also equal to 50 newtons. That's about it for our free body diagram. We know that we're looking for, the question is asking for, the coefficient of friction. The equation for coefficient of friction is mu is equal to the force of friction divided by the normal force. And in that case, looking at the force of friction to the left from our free body diagram is 50 newtons. Our normal force is 110 newtons. We end up getting a coefficient of friction that is 0.45. If you want to round it to the number of significant figures in this question, that would be to one significant figure, which would be coefficient of friction is equal to, or approximately equal to 0.5. That will also be accepted.